Now that we have the basic architecture and have a general of the heart and have the general sense of how it works, I want to turn our attention now into the various cell types we find in the heart. And I'm going to basically put it into two categories, two types of cardiomyocytes, one being non-contractile and the other being contractile. So I want to first talk about the non-contractile cells or the non-contractile cardiomyocytes. They constitute or represent about 1% of all the cardiomyocytes. So again, by far, not that many of them, but they perform a very, very important role. Within this class of non-contractile cardiomyocytes, we have specialized cells who have an ability to generate their own action potentials, completely autonomous. Nothing else from the outside causes the action potentials to happen. So they're totally autonomous and can generate periodic action potentials. And so what I want to do in this next block is basically talk about how all this works. So we would call those autorhythmic, which again, the name pretty much tells you, auto, self-generating rhythm. And these are the cells that will do that. Another name that you will see them called or referred to as pacemakers. Again, same idea, that they're generating periodic action potentials in their pacing. Now, it is these periodic action potentials that are actually going to cause the heart to beat. So every time these specialized cells have an action potential, that is going to result in the beating of a heart, and then a little less than a second later, it'll generate another action potential, and then that will be another heartbeat, and so forth, so on. So I'm going to speak in generalities here, but there are three types of cells that can serve as pacemaker cells. Again, it's a little bit of an oversimplification, and we'll get into some of the weeds on this in the later lectures, but let's make it simple for now. So what you have here is a group of cells, and we're calling this the sinoatrial node, and we're going to shorthand it and call it the SA node. And the SA node is going to be right up here, okay, and it is near where the superior vena cava, and then we have an inferior vena cava, okay, which is there, is interphasing with this right atrium. So these specialized little cells called the SA node are going to be generating periodic action potentials. So they're going to be, their baseline tends to be around 70 to 80 action potentials per minute. Then we have another set of specialized cells, and these are going to be the atrioventricular node, and we're just going to shorthand that and call that the AV node. So there is my AV node here, and the AV node is also in the right atrium, but it is in the base of the right atrium, very near the tricuspid valve, or the AV valve that's between the right atrium and the right ventricle. So it also has an ability to self-generate action potentials, and its basic pacing is going to be anywhere from 40 to 60 action potentials per minute. And then the third general category we're going to call the bundle of His and Purkinje fibers. The bundle of His is going to be just this area right here downstream from the AV node. And then that bundle of His, these fibers are going to bifurcate and form here, and this is going to be called bundle branches. And so I'm going to have a left bundle branch, I'm going to say BB for bundle branch, and over here will be my right bundle branch. Okay, and they're going down the septum of the heart, and they're going to round through here, and then they're going to end up with these Purkinje fibers. And these Purkinje fibers are just going to be little branches that are going to be interphasing with cardiomyocytes that are of the contractile nature. And so they have their own inherent pacemaking, and they're going to be having action potentials anywhere between 20 to 40 action potentials per minute. So you may be asking yourself, well, if the heart is beating 70 beats per minute, which is typical, and I'm having all of these autonomous cells being able to generate action potentials, and if the action potentials then are causing contraction, that doesn't seem to work out very well because everybody's doing their own thing. So here is a key principle that I need for you to get your mind around, and we're going to be reviewing this over and over throughout the next few lectures, and that's the following principle, is that the fastest pace, the group of cells that will have action potentials in the fastest pace are the ones that's going to rule, and they will actually suppress the autonomous action potential generation of these other cells. So the fastest of these is going to be the SA node, which means they're going to be lighting off 70 to 80 times per minute. So if they're having action potentials 70 to 80 times per minute, the generation of those action potentials will actually suppress the pacemaking ability of the AV node, bundle of His, and the Purkinje fibers because they're the fastest pacing cells. So what that means then is that these cells right here are not going to be generating action potentials. They're going to be suppressed by the SA node. The general rule is the faster pacemaking cells will suppress any other pacemaking cells in the heart so that they no longer generate action potentials. So we would say or categorize these last two as latent pacemakers. Okay, they're there and they have an ability to generate action potentials, but they won't because they're being suppressed by the pacing of the SA node. In normal individuals that are healthy and everything, the contraction of the heart is going to be generated by the pacing of the SA node, the sinoatrial node. And so when that happens, in clinic, you'll be referring to this as a sinus rhythm. So a sinus rhythm is just a medical way of saying that the SA node is the one that is driving the pacing of the heart and in terms of its contraction. Okay, so I'm just going to go ahead and cut this one short so I can get into the next section as one block. So I'll see you next time.